All right, so now we're going to be talking about our next organic family. These are the esters. These compounds are actually responsible for some of our more pleasant smells. So things like raspberries, coconut, pineapple, that sort of thing. All right, so first we're going to talk a little bit about the general structure. So an ester is a carbonyl of is a combination of a carbonyl and an alkoxy. So you can see that right here. We have our carbonyl and we have our alkoxy. So it is the functional group is a carboxyl derivative, and our organic family or molecule type is an ester. All right, so the first property we're going to talk about is polarity. So these molecules are polar. We've definitely got a polar bond there between the carbon and the oxygen. And so this is going to give us an uneven distribution of electrons, so we will see a partial negative charge and a partial positive charge. We can also see this in mole view, where we have a concentration of electrons around the oxygen. So again, these are going to display dipole-dipole interactions. All right, next we're talking about solubility. These will have the ability to accept a hydrogen bond from water. So that's going to help with their solubility, but just note that they do not contain a hydrogen bonded to an oxygen, so they will not be able to donate a hydrogen. But again, they can accept a hydrogen bond from water. And remember, oops, wrong pen. Remember that these do have lone pairs on the oxygen, so that does give it the ability to accept a hydrogen bond from water. Okay, and lastly is our ranking of phase change. So we're looking again at melting and boiling points. So lowest melting and boiling points are going to be our hydrocarbons, ethers, aldehydes, and then notice that esters are going to fall right in line with the amides. Amines will have a higher melting boiling point than alcohols, carboxylic acids, and then carboxylate ions.